Good morning, dear learners. In this video, we will be doing today exercise 2.2 of the chapter inverse trigonometrical function. We have done first exercise in the previous video, and I hope so you would have revised it and you are quite confident also. So, let us move ahead. Exercise 2.2, more application, more concepts, more varieties. It will be a test also, a sort of test. Why? Because you are going to apply the concepts of the first exercise, and you will also come to know new concepts. So, let us start. Let us go ahead. Yeah. Okay. So, we will be dealing with inverse trigonometrical functions. Function exercise 2.2. Now, before we start the exercise, I want you all to recapitulate some of the formulas that you did in class 11, like sine 2a. What was that? Sine 2a. It was 2 sine a cos a, right? Cos 2a. What was that? Cos 2a, we had three formulas, right? Cos square a minus sine square a, and also we had, if I write this cos square a into 1 minus sine square a, so it will become 1 minus 2 sine square a. Also, if this sine square a, we write 1 minus cos square a, this will become 2 cos square a minus 1 cos 2a. So, we had these three formulas. Remember, apart from this, we had formula sine square a plus cos square a equals to 1, sec square a minus tan square a equals to 1. Then we had cosec square a minus cot square a equals to 1, right? Now, in relation to these trigonometrical formulas, for class 12, we have formulas for inverse trigonometrical function. Some are for sine and cos, so I am putting a star so that you remember. Sine inverse x plus cos inverse x equals to pi by 2. Very simple, like the way you know all the formulas of class 10, similarly, and 11. Similarly, you will know for class 12 also, once you practice some questions, because this is tan inverse x plus cot inverse x equals to pi by 2. Okay. Next is cosec inverse x, then plus sec square x, sec inverse x equals to pi by 2. Then next is tan inverse plus tan inverse y equals to tan inverse x plus y upon 1 minus xy. Remember this formula. Tan inverse is also in minus tan inverse x. This is summation and this is difference, minus tan inverse y equals to, I am writing a bit below, rest you know understand rather, upon 1 plus xy. So, these are some formulas that will be used. Apart from this, there are some formulas which of conversion also. So, Let's make a note just now only, because once we'll start using, then it will be a matter of question mark from where this formula has come. Like sine inverse 2x, there's a conversion 1 plus x square. This will become 2 tan inverse x. How to use it? Once you do questions and you'll understand. Cos inverse 1 minus x square upon 1 plus x square is equal to 2 tan inverse x. Next is tan inverse x equals to, not equals to, 2x upon 1 minus x square equals to 2 tan inverse x. Apart from this, there are more conversion. Once we'll do some problems, no? Then as soon as the requirement is there, I'll tell you. Okay, let's start. Exercise 2.2. Here is your NCERT book. Now, this first question says that 3 sine inverse x equals to sine inverse 3x minus 4x cube, where x belongs to closed interval minus half and half. Okay, so let's start doing. Okay, first question says that 3 sine inverse x equals to sine inverse 3x minus 4x cube, where x belongs to half, and this you can write in bracket, half negative, this has to be negative, and half. Okay, so close interval negative, half and half. Yes. Now once you see this, don't you make out that 3x minus 4x cube, this you have used in class 11 also? Yes, there was a formula sine 3 theta equals to 3 sine theta minus 4 sine cube theta. Yes. So to get this, let's put x equals to sine theta. So RHS will become what? Sine inverse 3 sine theta minus 4 sine cube theta. Now this whole is a formula, so sine inverse sine 3 theta. So this becomes only 3 theta. Yes. Now, yes, in the previous video we discussed, like if x equals to sine theta, then theta equals to sine inverse x. So over here we can write 3 sine inverse x. Got it? Just use application of formula, nothing else. Got it? Here's a mark of happiness, the star for you. Let's move on to the next question. Now, few formulas of class 11 are there which you have to regularly use. So if you don't remember, you can go through the book of previous year you might be having, if you're not given to your juniors. You should keep it by the time you need it, and obviously you'll need it. Now this is cos. Now once you see this, again you get into the thought process that we have used this somewhere. Where we have used? Cos 3 theta equals to 4 cos cube theta minus 3 cos theta. Remember this formula? This was the formula. Yes. So we'll put x equals to cos theta. Simple. So we'll use RHS. So it becomes cos inverse 4 cos theta minus cos cube theta, rather 3 cos theta. So this one, now this one, this becomes cos inverse cos 3 theta. So cos cancels. So this becomes c theta. And in the previous question we discussed, if x equals to cos theta, then theta equals to cos inverse x. So 3 cos inverse x. That's it. Done. LHS equals to RHS. Got it? Simple? Yes. Let's move on to the next question. Tan inverse 2 by 11 plus tan inverse 7 by 24 equals to tan inverse 1 by 2. Now, once you see this question, you can relate this question to the formula that I gave you, formula list. Tan inverse A plus tan inverse B. Tan inverse A plus tan inverse B. What was it? Remember? Tan inverse A plus, this was tan inverse A plus B upon 1 minus AB. So we can use over here tan inverse 2 by 11 plus 7 by 24 upon 1 minus 2 by 11 into 7 by 24. Solve it. It's simple, taking LCM only. So I don't have space over here. So let's move on to the next page. You can continue. I'll rewrite this step. Just a minute. Tan inverse, this will become 24 into 11 is 240, 250, 264, 264, 24 to the 48 plus 77. Got it? Upon, this will be also 264. This will come over here, 264 minus 14. So this cancels. And then when you add up this, this comes 8, 7, 15. That is 125 upon 250. Cancel. So tan inverse. How much was the left hand side? Right hand side. 1 by 2. Yes, got it. Good. So this is your answer. Let's move on to the next question. This is question number 4. 2 tan inverse 1 by 2 plus tan inverse 1 by 7 equals to tan inverse 31 by 17. Now what do we have? Now you can see that 2 tan inverse is there. And once you see this, you can quickly go through the list of formulas that I gave in the beginning of this video. We can convert this 2 tan inverse theta into tan inverse 2 theta upon 1 minus tan square theta, 1 minus theta square. That's it. This you solve, cancel. So 2 to the 4 minus 1, 3, 3, 4 will go up, 4 by 3. This becomes 4 by 3. Plus, this remains the same over here. This over here and over here I am writing. Tan inverse 1 by 7. Now, what to do? Again apply tan inverse A plus tan inverse B. That was tan inverse A plus B upon 1 minus tan A tan B. That means 4 by 3 into 1 by 7. Solve it. 7 3 times is 21. Okay. 7 3 times is 21. 7 4 is 28 and this is 31. Okay. I'll use this space. It will be easier for you to understand. Over here we can instead of using the next page. So this becomes 28 plus 3, 31 upon 21, and tan is also there, tan inverse, upon, this comes 7, 3 is 21 minus 4, that is 17 upon 21. This cancels. Yes, we got the answer. Tan inverse 31 by 17. That's it. A star, sign of happiness. Got it? Let's move on to the next question. Question 5. Now they are saying write the following function in simplest form. Simplest form means just to solve. There's nothing so different that you are going to do. Tan inverse under root 1 plus x square minus 1. Minus 1 is separate upon x. Now, once you see this particular value, you have to substitute something so that we can get rid of this root. The first thought which comes into my mind is class 10 formula. Sin square theta plus cos square theta equals to 1, and sec square theta minus tan square theta equals to 1. Cosec square theta minus cot square theta equals to 1. This was there. Now 1 plus x square. So if you transfer tan over there, that side, so this becomes 1 plus tan square theta, that becomes sec square theta. So we can put x equals to tan theta. Can we think about it? Can we go ahead with this? So this becomes tan inverse under root 1 plus tan square theta minus 1 is separate upon tan. 1 plus tan square theta will become sec square theta, and sec square theta will come out, will become sec theta minus 1 upon tan theta. Now in class 10 also you would have heard teachers saying to you again and again, change into sine and cos. So we go ahead with the same, change into sine and cos. Sec will be 1 upon cos theta minus 1 upon sine theta upon cos theta. This is lengthy question but very easy. Tan inverse cos cancel, and this will become 1 minus cos theta upon sine theta. Yes. Now, do you remember, like just now in the beginning of the video where I told you sine 2 theta, we have formula 2 sine theta cos theta. In the same way, for sine theta, we will have formula 2 sine theta by 2 cos theta by 2. Half angle formulas. So in the same way, this 1 minus cos theta, you must be remembering tan inverse, this will become 2 sine square theta by 2, right? 2 sine square theta by 2, and this will become 2 sine theta by 2 cos theta by 2. This cancels. I am using this space. Okay, so this becomes tan inverse sine theta by 2 upon cos theta by 2. This will become, no, sine is there, just see. What will cancel? Tan theta by 2, this will become, yes, because sine will cancel over here, 2 will cancel, and sine upon cos is tan. So tan gone, so theta by 2, and what was theta? Since x was tan theta, so theta was tan inverse x. So we can write half tan inverse x. This is what we are supposed to prove. Got it? Simple. Comparatively simple. Just a substitution you have to remember. Let's move on to next question. Question number 6, which says that tan inverse 1 upon under root x square minus 1, where mod of x is greater than 1. Now, by seeing the question, you can make out what to suppose. In the previous question I discussed like sin square theta plus cos square theta is equals to 1, sec square theta minus tan square theta equals to 1, cosec square theta minus cot square theta equals to 1. So, if you put cosec theta x equals to cosec theta, what will happen? It will become tan inverse 1 upon under root cosec square theta minus 1. Yes? And cosec square theta minus 1 is what? Cot theta. So, tan inverse 1 upon cot theta. This will become cot square theta, and then ultimately this will move out of the root. 1 upon cot is what? Tan. Yes, tan theta. Tan inverse. So, what happens? Only theta is left. And theta was what? Cos inverse x. That's it. Cosec, not cos. Got it? I have taken small pause just to make sure that you understand. Next, let's do on the next page, because next question seems to be a slightly lengthier one. This is question number 7. Tan inverse under root 1 minus cos x upon 1 plus cos x, where value of x is lying between 0 and pi. Now, just see this question, go through it. 1 minus cos theta. I told you in the previous question also, previous to previous question, this is what? This is 2 sin square theta by 2, 2 sin square, this is x by 2. Why? Because x is there instead of theta. And 1 plus cos x, this will become 2 cos square x by 2. This you have to remember, these two identities. 2 cancel, sin upon cos tan, so this becomes tan square tan x by 2. Tan inverse tan x by 2. Okay, tan gone, x by 2. That's it. What was x? That's it. No need to. We have not done any substitution over here, so no need to. Yeah, that's it. Okay, let's move on to next question. You're finding easier, I hope so. Sin x upon cos x plus sin x, and value of x is lying between x and pi. Now, once you see this question, what do you feel like? Okay, somehow I have to convert what? The inner values. So, first thing you have to change into some formula of tan. So, first change, see, we know sin upon cos is tan. Why not to divide these, dividing by cos? If you divide by cos theta, what happens? This becomes tan inverse cos theta upon cos theta minus sin theta upon cos theta upon cos theta upon cos theta minus sin theta upon, this was plus cos theta. So, this cancels, this also cancels, so this becomes 1 minus tan theta upon 1 plus tan theta. See, maths is all about practice. Now this you have to convert into formula of tan. Now, you know 1 is what? 1 is tan pi by 4. Tan inverse. Next time whenever you see this question, this type of question, you will immediately connect. First time you might be feeling this also. 1 plus, this we can write 1 into. Can we write 1 into? So, we can write tan pi by 4 into tan theta. Remember, this tan theta I have written 1 into. Done. So, this whole becomes the formula of tan pi by 4 minus x. I am doing that over here. Oh, okay, let me move to the next page. I have to do hodgepodge. So this becomes tan inverse tan pi by 4 minus x. So tan gone. So pi by 4 minus x. This is your solution. Got it? So this page is finished. Now let's move on to the next page. We have 21 questions. All are simple. Next is question number 9. Says that tan inverse x upon under root a square minus x square. Now again think of substitution. Now remember, when you are thinking for substitution, and there is one thing more written over here, mod of x is less than a. When you are thinking of substitution, only if you substitute x equals to sine square theta, then a is also there. So you have to also take a along with it. So x equals to suppose be a sine theta. Suppose be. Why I am taking sine, not cos? Because sine upon cos is tan. Tan inverse a sine theta is a upon a square minus a square sine square theta. So this a will come out and cancel a. So it will become sine theta, and inside it will become 1 minus sine square theta. So this will become cos square theta. Yes, and cos will become cos theta because root was there, sine upon cos theta. So sine by cos is tan. So this becomes only theta. Tan inverse tan theta. This is only theta. That's it. And what was theta? Tell me now. We have supposed in this question. So once you suppose, what happens? Theta will be x upon a, sine inverse. How this comes? See, x equals to a sine theta. This was theta. A will come this side, x by a equals to sine theta. Theta equals to sine inverse x by a. Got it? Easy? Let's move on to the next question. It's all about substitution. So there is nothing to worry. Just a practice once or twice. That's it. Done. Question number 10. Tan inverse 3a square x minus x cube upon a cube minus 3ax square. They have also written a is greater than 0 and value of, you don't have to be concerned with this, but there is a logic behind it. You don't have to get scared. Value of x lies between minus a by root 3 and plus positive a by root 3. Okay. Now think of a substitution in this question. Can we substitute something? The same thing, a tan theta. X equals to a tan theta. Why we are using a? So that we get common. So tan inverse 3a square into a tan theta. This is smaller one. I often make bigger one. Minus, you must avoid a cube tan cube theta upon a cube minus 3a into a square tan square theta. Got it? So this will be tan inverse. This will become what? Can you take something common? We'll take common. This will cancel. What is left? 3 tan theta minus tan cube theta, because a cube is cancelled. Yes, upon 1 minus 3 tan square theta. Now this becomes formula of tan 3a, tan 3a theta. Okay. Now tan cancel. What is left? 3 theta. Yes. So now what we have supposed? X equals to a tan theta. So tan theta equals to x by a. So theta will be, we have done in the first exercise this transformation. So 3 tan inverse x by a. This is your final. Okay, I'm putting a star mark of happiness. Got it? It's quite simple. Just a conversion you have to, this substitution you have to remember. Okay. Now, next they are saying that like find the value of each of the following. Now, this is comparatively simple. You need to just find the, this is n is over here. Okay. Find the value of yes. Now, you know how to solve it. How to solve it? Always start from the innermost bracket. Like sine inverse is there, half we can write what? Half we can write sine, half is 30, so pi by 6. 2 sine inverse sine pi by 6. Sine gone, so 2 into pi by 6, 2 3s are, so 2 into pi by 6, so this cancels, so this becomes pi by 3, cos pi by 3, 2 times. Now cos pi by 3 is how much? Cos pi by 3 is cos 60. Yes. Yes. So how much this will become? Quickly tell me. 1 by 2. Yes. See, sine 30 is 1 by 2 and cos 60 is 1 by 2. Cancel. So tan inverse 1. 1 is what? Tan 45. So it cancels 45 degrees. So you can write pi by 4. That's it. It's just solving from the innermost bracket. I hope so you have understood. Okay. Let's move on to the next question. Question number 12. Cot tan inverse A plus cot inverse A. Now, tan inverse A plus cot inverse. You know, this we discussed in the beginning of the class that this is equal to pi by 2. So cot pi by 2, how much is it? Cos pi by 2 upon sin pi by 2, that is 0. That's it. Got it? So just an application of formula. Let's move on to next question. Next is, all are simple. Remember, you'll practice 2-3 times, you'll be very fluent. Okay. Now again, think of substitution. What you can substitute over there? There is no need to substitute. These two formulas I told you in the beginning of the video. So tan half, this is actually 2 tan inverse x. Yes. And what one is this? Plus this is tan y. So 2 tan inverse y. Yes. 2 cancel, you'll take common tan, and tan inverse x plus tan square inverse y is what? Tan inverse x plus tan inverse y. This forms a formula. What? Tan inverse x plus y upon 1 minus xy. Outside is tan. Tan cancels. So this becomes what? X plus y upon 1 minus xy. That's it. Got it? Very simple. So over here just we have used a formula. That's it. Tan inverse A plus tan inverse B, tan inverse A plus B upon 1 minus AB. Let's move on to next question, question number 14. Is also very simple. Sine of sine, there is also if inverse 1 upon 5 plus cos inverse x equals to 1. Find x. Now once you see this question, you can think of conversion or transfer. So I'm using transfer. It's easier actually. 5 plus cos inverse x equals to, this will go that side, sine inverse 1. And what is sine inverse 1? See, I am solving it over here instead of sine inverse. 1 is sine 90, sine pi by 2, sine cancel, this is pi by 2. Sine inverse 1. Okay, so we can solve like this. So this is, we can write as sine, not sine, pi by 2. Okay, sine inverse 1 by 5 plus cos inverse x equals to. Now once you reach over here, there is hardly any problem. Why? Because once you transfer this that side, what will happen? Sine inverse 1 by 5 will be equal to pi by 2 minus cos inverse x, and this will become what? This will become sine. Now you can compare these two. So value of x will be 1 by 5. Got it? Mark of happiness. Very simple question. Another simple question is coming up. Tan inverse x minus 1 upon x minus 2 plus tan inverse x plus 1 upon x plus 2 equals to pi by 4. Find x. Same thing. Remember the formula? Tan inverse A plus tan square B inverse B. So this will become tan inverse A plus B, x minus 1 upon x minus 2 plus x plus 1 upon x plus 2 upon 1 minus x minus 1 upon x minus 2 into x plus 1 upon x plus 2. Can you solve this? In the numerator part, you can take LCM, and in the denominator portion, you can take the LCM after multiplication. So let's solve it over here. This gives rise to, see, this these both will lie over here. So it will be a case of x minus 2 and x plus 2, both will be LCM. So 1 will multiply that side, x minus 1 into x plus 2 plus, and this will go that side, x plus 1 into x minus 2 over, this will go this side, this will become x minus 2 into x plus 2. Now x plus 2 and x minus 2, when we write this, and then automatically it comes into our mind a plus b, a minus b as a square minus b square. This cancels with this. Yes. Numerator you can solve. Numerator you can solve. This will become, multiply it. this will become x square, then you multiply inside plus 2x minus x minus 2 plus x square plus x minus 2x minus 2 upon x square minus 4 minus x square minus 1. Solve it. 2x square, this will cancel, this cancels with this, 2x also cancels, 2x square minus 4 upon where x square cancels, minus 3 equals to 1. Once you solve it, 2x square minus 4 equals to minus 3. So x square this equals to 1, x will be equal to plus minus 1 upon root 2. That's it. Easy? Got it? Good. Let's move on. The next question is, now we got multiple choice, very simple questions. Again, find value of 16, sine inverse sine 2 pi by 3. Now, sine inverse sine 2 pi by 3. Think about it. When we see 2 pi by 3, can we reduce it? Sine inverse, can we reduce it by using pi or 2 pi? Now, what is the value of x lying between? It lies between minus pi by 2 and pi by 2. Yes? And that also closed. In the previous video, we have done that's the principal value of sine, cos, tan, cosec, sec, cot. So it won't be a problem, I suppose, for you. So we can write pi minus pi by 3. Can we write? Pi minus pi by 3. Can we write? So sine 180 minus theta is what? So sine inverse, this will further become sine pi by 3, correct? Cancel, so this becomes pi by 3, correct? Because this belongs to what? Minus pi by 2, comma pi by 2. Agree or not? Simply star, sign of happiness. Another question we have of the same type, tan inverse tan 3 pi by 4. 3 pi by 4 also you can solve in the same way. Tan inverse tan pi minus pi by 4. Yes. So this will come how much? Try doing yourself. 180 minus pi by 4. How much is that? Tan inverse, this is tan pi minus pi by 4. So this will become minus tan pi by 4, tan inverse minus tan, so we can insert inside tan inverse tan minus pi by 4. Yes, this we have done in the first exercise. There should not be a problem. So minus pi by 4. That's it. Got it? Now you must be wondering why this is minus pi by 4 and this was pi by 3. See, I'll explain this by this table. Add sugar to coffee. Remember, after add sugar. So in this quadrant, sign is positive. So that's why it was positive over here in this case. Got it? And this is negative over here because in the second quadrant, tan is negative. Next question we have tan sine inverse 3 by 5 plus cot inverse 3 by 2. Okay. Now this also you go with the same conversion like we have done earlier also. Okay. So sine can be changed into tan. Class 10, remember? Tan was sine upon cos. So if you refer to theta over here, let's suppose this is A, this is B, this is C. So if sine is known 3 by 5, easily we can get tan. Can we get or not? So tan will be what? Sine is perpendicular upon hypotenuse. So this is 3, this is 5, automatically it becomes 4. So tan inverse 3 by 4 plus cot. Now cot is what? Base upon perpendicular. So another one I am making for you. Base is this and perpendicular is this. So what will be tan? Very simple. 2 by. So this will be tan inverse 2 by 3. Correct? Now you can use tan formula. Tan inverse 3 by 4 plus 2 by 3 upon 1 minus 3 by 4 into 2 by 3. Tan is outside. So this solve. Tan, how much this will become? 4 3 is 12. So this will become tan inverse 12. 9 and 3 4 2 is 8. 9 and 8 17 upon 4 12 minus 6 6 upon 12. This cancels, 17 by 6. Tan 10 gone, 17 by 6. This is the value. Got it? Here's a star. Mark of happiness. Don't be tired. We as humans need not to be tired. Keep moving. Here we go with the next question. That is cos inverse cos 7 pi by 6. They have also given options. A is 7 pi by 6 and B is 5 pi by 6 and C is pi by 3 and D is pi by 6. Yeah, they have given 4 options. Now 7 pi by 6, can we solve it by using pi or 2 pi? See, using pi is not a good option. So better you use 2 pi. 2 pi minus pi by 6. Is it right option? 6 to the 12 minus 1. No, it's not working. So minus 5. Can we attach 6 to the 12 minus 5 7? Yes, got it. Now go to the quadrant, add sugar to coffee. 2 pi first and second. Okay, so this will become what? Cos 5 pi by 6 and cos gone, 5 pi by 6. So which option is correct? B is correct. Mark of happiness. Got it? Good. Let's go with the next question. Sine pi by 3 minus sine inverse minus 1 by 2 is equal to. Now they have given options also. A is half and B is there 1 by 3, C is there 1 by 4 and D is also there 1. solve it in the same way like we did the previous question. This one is sine. So this we can solve from the inner bracket. Let's sine pi by 3 minus this half we did in the first exercise. Remember, half. No? This minus half, what will we do? We can write minus sine pi by 6. Can we write? Next step, sine pi by 3 minus sine inverse. This we can write sine side. Sine minus pi by 6. Yes? We have to move to the next page. Once we reach over here, then this one sine gone, so it becomes sine pi by 3 minus will become plus pi by 6. Got it? I hope so. This is clear. Now once this much is done, then you can easily solve it. So this will become this 3 to the 6 2 pi plus pi to sine how many pi? 3 pi by 6. So this you can cancel. Sine pi by 2 it will become. Sine pi by 2 is 90. Sine 90 is 1. That's it. Got it? So 1 is the correct answer. I hope so this is clear. Okay. Let's move on to the next question. Question number 21, which says that tan inverse root 3 minus cot inverse negative root 3. This is also quite simple. They have also given 4 options. One is pi, second one is negative pi by 2, third one is 0, fourth one is D option is 2 root 3. So let's go ahead. Tan inverse, now root 3, quickly recapitulate the table you did in class 10. Root 3 is tan pi by 3, that is 60, tan 60. So we can write tan, only 60 is left, 60 is pi by 3 minus cot inverse. Now minus to what we can write? Minus cot pi by 6, and remember cot is there. Wherever cos is there involved, then what we do? We change into theta. Change the theta, pi minus pi by 6. There is also cot over here. Cot inverse is also there, and cot is also there. This has to be over here. I was overexcited. 6 pi minus pi by 5 pi by 6, just to explain you. 3 minus cot inverse. Cot cancels now, but no need to write. So this once you solve, take out LCM. LCM is how much? 6. So this is 2 pi minus 5 pi. So this comes how much? This is negative 3 pi by 6. You can cancel this. This becomes 3 2s minus pi by 2. Which one is the correct option? Correct option is B. Got it? So here is a star mark for happiness. So this all we had. There were 21 questions, all questions we did, and it was really wonderful. I hope so every question you have understood. Now it's not only like understanding everything, you need to practice again and again. Practice will bring efficiency in you. Okay? Yes? No? Now so you went through each and every question. of second exercise of inverse trigonometrical functions. I hope so everything is clear. Each and every question is clear. Yes? Okay. Best wishes. Revise each and everything again so that you are perfect. Excellence. Okay, excellence, something which matters in the space of time, 2020. Okay? Best wishes. Take care.